Welcome to Lesson 6 for Saxon Math Intermediate 5. Today we'll be talking about adding whole numbers. Our objectives for this lesson. After this lesson, you should be able to identify the commutative property of addition and use it to add several one-digit numbers in any order. Identify the identity property of addition and use it to find the sum of any number in 0. Use the addition algorithm to add 2- and 3-digit numbers. Some review from the last lesson. You can use expanded form to help you name numbers. Hyphens are used when naming numbers from 21 to 99 that don't end in 0. And never ever use the word "and" when you are naming a number unless it has a decimal point. And when you're naming money, don't forget the three words dollars and cents in addition to your number words. Our new concept, which isn't really that new to you, is about adding. So we're going to start with knowing the parts of an addition problem. The numbers that we're adding together are called addends, and the number that is created by putting the addends together is called the sum. So here's an example, just a simple addition problem. 6 plus 3 equals 9. 6 and 3 are the addends, and 9 is the sum. Let's talk quick about the commutative property of addition. To commute means to move from one place to another. So you commuted to school today, whether you rode the bus or one of your parents drove you, or even if you walked or rode your bike. You commuted from your house to school. So this property of addition illustrates that addends, those numbers we're adding together, can be written in any order and it will not affect the sum. Your answer is going to be the same no matter what order you add the numbers in. Here's an example. 6 plus 4 is 10, and 4 plus 6 is also 10. It doesn't matter if you switch the 4 and the 6 around. Here's another example with more than 2 numbers. So if we have more than 2 addends, you can put them in any order and they're going to be the same. All 3 of these use the same 3 addends, so the answer is 16 no matter what order they're in. The identity property of addition. The identity of a number does not change when added to 0. So it makes sense because when you add 0 to something, you're adding nothing, so nothing will change. It's going to be the same as the other number, the other addend. So here's your example. 5 plus 0 equals 5, and if you switched those around with the commutative property and did 0 plus 5, it would also be 5. Same with this one. Now, we'll talk about the addition algorithm. An algorithm is a method for doing something in math that always works. So this only works if you make sure you line up all of your digits that have the same place value. So if you're going to write 287 plus 365, you should not leave it horizontal like this. You should make sure it's like this, where my ones places are lined up, my tens are lined up, and my hundreds are lined up, so that I can add the same place value numbers together. Okay, so let's talk about money. Imagine we were doing $287 plus $365. And this is going to get a little confusing using words, but I'll show you in a picture after this, so bear with me. So you start by adding your $1 bills. So you add $7 plus $5 and you get $12. We take a $10 bill from the $12, leaving only $2. Then we add the $10 bills together, and we get $80 plus $60 equals $140. Plus the 10 we took from the $1 bills, that makes $150. So then we take $100 from the 150, leaving $50. Next we add the $100 bills. $200 plus $300 equals $500. Plus the $100 we took from the $10 bills makes $600. So then we put all the final sums together. $600 plus $50 plus $2 is $652. So like I said, now I'm going to show you that addition problem with pictures. So here we have our $287. And over here, we have our $365. So we're going to add these two together. Like I said, first we add together our $1 bills, and we end up with 12 of them. So we take 10 of our $1 bills away, leaving only the 2 singles, and we have to add an extra. That 10 we exchange for a $10 bill. Next we add our $10 bills, so we end up taking 10 of those away, leaving us with the 5, and then we're going to add another $100 bill using those $10 bills. So now you can see we end up with 100, 200, 300, 400, 500, 600, 10, 20, 30, 40, 50, 2. So 652. Now we're going to do the exact same thing, but using just pencil and paper. No pictures, nothing like that. So we're going to add our ones place first. 7 plus 5 is 12. So we put our 2 down at the bottom, and we carry our 1 above the tens. That's like exchanging those 10 singles for one $10 bill. Then we're going to add our 8 plus 6, which is 14, plus the 1 we added from the ones place. So that would be 15. So we keep our 5, and we carry a 1 over the hundreds place, just like exchanging those $10 bills for a $100 bill. 3 plus 2 is 5, plus that 1 that we carried is 6. So that's what's called the addition algorithm. That's all for today's lesson. Make sure you answer your practice problems and write down any questions you have in that discussion section, and we will talk about them next time. We'll see you in lesson 7.